Let's take another look at the integral of the tangent to the fourth power of x with respect to x. Because can this integral be equal to the integral of y to the fourth power over y squared plus 1 with respect to y? And if it can't be, how do we come to this formulation? So previously we've looked at defining the integrals of powers of tangent with the reduction formula. But I think this is a shorter and more clever way of doing it. So instead of going through a mechanical process like using a reduction formula, let's try and see if we can change the variable completely. And to do that, I'm going to let the tangent of x equal y. So that means tangent to the fourth power of x is equal to y to the fourth power. And that of course means the integral of tan to the fourth power of x dx is equal to the integral of y to the fourth power dx as well. But to complete the change of variable, I have to integrate with respect to y on the right hand side. So let's call this tan x equals y expression 1 or equation 1. Let's call the integral of tan to the fourth power of x dx equals the integral of y to the fourth power dx. Let's call that equation 2. From equation 1, with y equals the tangent of x, let's take the derivative. So dy dx is equal to the derivative of the tan of x is equal to the secant squared of x. And by the Pythagorean identity, which is sec squared x is equal to tan squared x plus 1. So I have here sec squared x equals tan squared x plus 1. Well, the tangent of x is equal to y. So the tangent squared of x is equal to y squared. So we have the expression dy dx is equal to y squared plus 1. And now let's shift things around a bit and let's get all the y's on one side and all the x's on the other side. So I'll move the differential dx upstairs. So we have dy equals dx. And I'll move the y squared plus 1 downstairs. So on the left hand side we have dy on y squared plus 1. So equation 2 becomes the integral of tangent to the fourth power of x dx equals the integral of y to the fourth power. And here we have the expression for dx, which is dy on y squared plus 1, which I can write more neatly as the integral of y to the fourth power over y squared plus 1 dy. So let's find the result to this integral. To do so, I'm going to do some manipulation of the integrand. So let's write the integrand y to the fourth power over y squared plus 1. I'm going to subtract a 1 and add a 1 to the numerator, because in effect here I'm doing nothing. Now I'm going to separate. So the first two terms I'm going to group together. So we have y to the fourth power minus 1 over y squared plus 1. And the second fraction we have 1 over y squared plus 1. Now the first fraction, y to the fourth power, let's write that as y squared all squared, and then minus 1. Minus 1 can be written as also 1 squared over y squared plus 1. Now I have the difference of two squares, and let's copy down the second fraction as well. So we still have 1 over y squared plus 1. So the numerator on the first fraction is the difference of two squares, and the difference of two squares can be expressed as y squared minus 1 by y squared plus 1. So now these two can cancel, and I'm left with y squared minus 1 plus 1 over y squared plus 1. So the integral of y to the fourth power on y squared plus 1 dy is equal to the integral of y squared dy minus the integral of dy. So effectively we're separating these into three separate integrals, plus the integral of dy on 1 plus y squared. So the first integral is simple enough, it's just a power integral. The result is y cubed on 3, increase the power by 1, divide by the new power, minus the second integral is simply y, and the third integral is arctan, or the inverse tangent of y. Okay, I'll link a video to how we get this result in the description, and don't forget the integration constant plus c being an indefinite integral. Okay, now that we have the result, let's not forget that earlier we made a change of variable, and it's similar to how we would do integration by substitution, but we made a change of variable where we declared y equals the tan of x. So we have to back substitute this into the result that we just got. So that's the integral of tan to the fourth power of x is equal to the tangent cubed of x over 3 minus the tangent of x plus the inverse tan of the tan of x plus c. And of course the inverse tan of the tangent will simply cancel each other out, and we are left with x. So just rewrite this. The integral of tan to the fourth power of x is equal to tan cubed x on 3 minus the tan of x plus c. And if you compare this result to the previous video where we use the reduction formula, you'll find that is exactly the same. So there you go. That'll do it for this video. Best of luck with your math studies, and I'll see you on the next one.